Another draft physics video presentation. Inside. Anyway, second time making this video. Got an hour into it and power failure. Yay. So that's annoying. All lost. So this was a response, basically gravitational waves. There were no comments that were reasonable. Wise Monkey left some stupid comment, and I commented how it's a stupid comment and just left it at that. And then I played this video. And well, anyway, so I'll do it again, I suppose, because the subject's worth talking about. But you know, I'm just kind of already shot my load. It's harder to be interested. I mean, I have to wait a few hours to gain any more enthusiasm. But anyway, so we'll do it. Context. After hearing it, like I said, there's just nothing in this video. It's mush. But anyway, but yeah, the context is this is an impossible thing they were trying to do, and they made it somehow. They just created the illusion that they did it, and it's all just a huge fraud. And science should be embarrassed. It will be in the future because it'll be found to be rubbish science. It's all made up, and the part that I find offensive, which is ironic in a sense, just because I think Einstein was wrong. Okay, this bent space guess was stupid. It is spooky action, blah blah blah, all those arguments. But Einstein was still a human being, and it is shameful how they're trying to smear Einstein's credibility on this horrible science and pretend that Einstein theorized any of this crap at all. Einstein thought of gravity waves merely as the motion of mass. When you move masses, you change their field. Just like if you move charges, just as you move magnets, you change where the magnetism is. The gravity moves with matter. And that if you're moving the matter, you'll have a change in the gravitational field. That's it. Einstein had no theory of converting matter into gravity waves or bent space or any of that crap. It's just nonsense. His theory was basically a duplication of Maxwell's theory when it came to electromagnetic radiation, and Einstein was merely applying that same theory to the function of gravity, and essentially and so instead of a virtual photon, there was some mediator for this change, and the change was an attractive force. And so which is different than the charge forces, obviously, because it has attraction and repulsion, and those differences are real, but not they don't account for any of the physics they're applying. So the point is, Einstein didn't say anything about these kinds of gravity waves. What they're calling a gravity wave has nothing to do with what Einstein thought about, talked about, wrote about, or said anything about. And they're just lying to pretend this is something to do with Einstein. It has nothing to do with Einstein. They've made all this theory up.
It begins with Albert Einstein.
No, it doesn't. It really doesn't. And even without Einstein, why is this computer doing silly? Stop it, printer. Could you please stop doing that? Whatever you're doing, stop it. I'll pause until I don't want to turn it off. Although it really doesn't matter. Alright, I'll pause and resolve it. Almost forgot to turn it back on. So anyway. Always something. Power failures. Anyway. So this has nothing to do with Einstein.
A little over 100 years ago, Albert Einstein predicted the existence of gravitational waves.
Okay, now, anybody who Newton would have predicted it. Okay, what Einstein was saying about gravity waves isn't any different than what Newton would tell you if you told Newton that two objects just moved, or two objects were spinning around each other. He would say, yes, their gravity profile subtly changes. So when they're like this, their center of gravity is here. When they're like this, their center of gravity moves back a little bit. Okay, that's it. I mean, the change is tiny and subtle and blah 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 blah. Well, it's like this as it moves back a little bit. So when they're like this, the center of gravity moves back a little bit. because as you're moving this way, you're weakening the force in that direction. And it's a subtle weakening, but it exists. And so it all is it's just a subtle dimming of a light bulb. So the light bulb is bright, dim, bright, dim, bright, dim, bright, dim. But the amount is so small that you won't see it, okay? And you certainly won't see it from a billion light years away.
He formulated his theory of gravity, called general relativity, and he used the equations of his theory to make this prediction.
So again, he didn't use the equations to make the prediction. The prediction, anybody who knew anything about gravity and anybody who was associating gravity with matter, Newton, obviously, M1, M2, anyone who knew the gravity was created by the material object, and the material object is made of smaller and smaller parts, but you can make smaller and smaller pieces of matter, okay, would know that, yes, of course, you move the objects, you change the gravitational profile. And the gravity wave is just a change in the gravitational profile. That's all Einstein was saying, okay? So they're just lying that there was some other Einsteinian innovation, okay, that made this all special. No, Einstein's complete conversation about gravity waves just has to do with moving matter. So you have an event that moves matter, an explosion, whatever. The matter moves, you'll change the gravitational profile. That's all Einstein was conceding or saying. And it had nothing to do with his theory. It wasn't special to his theory. It was special to any theory of gravity that recognizes that mass creates the effect of gravity. Any theory that says that will say, yes, there are gravity waves in the sense that you fluctuate the gravity based on how the objects are moving.
Told us that there should be these waves that travel across the universe, and that their physical manifestation is that they stretch and squeeze space.
All right, so this is more crap. So Einstein didn't say anything about squeezing in one direction and expanding in another direction. The gravity is a convergence, okay? It pulls in, okay, to the mass, and it doesn't pull out at the top and in at the sides. None of that happens, so that's more crap, just nonsense they're putting in Einstein's mouth. Einstein didn't say anything about gravity expanding in one dimension and contracting in another. Didn't happen. Space-time doesn't do that. I haven't seen Susskind say it does that, so why are they saying it does that? Oh, I find out later. They're saying it because it's the only way their theory can work. So just like Einstein made photons twice as affected by gravity, they, to make their interferometer work, they have to double the effect. So not only are they saying we're detecting 1/10,000th of a thread, they have to double it. And they double it by saying one arm is contracting while the other arm is expanding. So they have to make the two dimensions have a different effect on the arms to double the signal, because the signal is still too weak. Even though they did all this crap to make the signal stronger, this fake let's burn solar masses and turn them into fake space bullshit that Einstein again never said anything about. There's the only way they can make it work is the only way they can even propose something that's not completely laughable even as mathematics is they have to create a fake doubler. And that's all that is. They need it to expand one way and contract do the opposite. So the opposite of what photons do, they're supposed to be expanded. The magnetic field and the electric field both expand at the same time and both contract at the same time. They had to make gravity waves do the opposite so they could detect one arm is shrinking while the other arm is getting longer. So they had to double their signal, their fake signal that they never, again, they heard Putin's horse fart. That's what the signal was. It has nothing to do with anything fucking celestial.
What that means, in more technical terms, is if you have two inertial reference frames, one here and one there, as the gravitational waves goes by, the inertial reference frames move back and forth with respect to each other. That means that if you have...
Well, again, they each one individually is affected by the gravity. So again, this is more nonsense. They move because there's a change in the field you could call gravity. Whether you call that bent space, it doesn't really matter. The point is that the space is contracted or expanded in the sense that it's either contracted or not affected. This is probably a better way to say it. Whether or not it rebounds, that's a whole nother subject. The contraction exists for a moment in time, and then the contraction stops. So that's sort of what you could call it. So it pulls, and then it doesn't pull. And it pulls, and it doesn't pull. The light's on, the light goes dim. The light goes on, the light goes dim. It's not any different than that light bulb going lighter and darker. So there's nothing special about this stuff.
Have two particles that are sitting one here and one there. As the waves pass, the particles always try to remain inertial, so they're pushed back and forth with respect to each other.
Okay, so again, this is more, again, it's just a complicated way of saying it, right? Like, all you have to do is think of gravity as a light bulb in reverse. Okay, if the light hits you, it pulls towards you. All right, it's an attractive force. So if you're seeing a photon, it means the attractive force hits you. Now, unlike light, we're not talking about gravity reflecting off of objects or any of that kind of stuff. So let's not bother with the reflections. We're just talking about sources. And each little thing is a source, and it's giving off a certain amount of this light that attracts you. That's all that gravity is a theory, even by Einstein. That's what gravity does. That's why it moves the same speed as light, because it's functioning the same way as light. That's why Maxwell's straight lines of force, completely endorsed by Einstein, and they're the source of the inverse square law, which is also perfectly endorsed by Einstein. So you can understand there wouldn't be an inverse square law if there wasn't straight line radial force. The force acts just like photons, except it's an attractive rather than repulsive piece of energy.
But there's a stretching along the horizontal direction if the waves are propagating into the screen, while there's a squeezing vertically. And then when there's a stretching vertically, there's a squeezing horizontally. So that's what the pattern would look like if the wave went through a set of particles.
Again, just more nonsense. There's nothing. Where did Einstein say that happens? Where's that in Einstein's theory that spherical objects have more gravity up and down than they have left and right? Where did Einstein say that? That it's a completely different kind of bent space up and down than it is right to left. Where did he say that?
Now, Einstein wrote a technical paper describing these gravitational waves.
Right, and the description wasn't a description of gravitational waves. It was a description of just the basic effect of moving material objects that produce gravity, an effect of gravity. So you have objects that produce the effect of gravity, and you move those objects around each other, or you explode them, or you do something else radical to them, that you'll change where the mass is located, and by changing where the mass is located, you will change the gravitational profile. That's all. That's all Einstein conversed about, is whether or not you could detect those changes. And his conclusion was no chance.
1916, just 100 years before we announced the discovery of the waves. And he said in that paper, these waves, or any phenomenon that occurs in the universe, he said in effect, it wasn't quite in these words, these waves will be so weak that humans are unlikely ever to detect them. However,
he said they're not, you won't detect them because there's no theory for their detection. There's no theory that something, we can't even detect the gravity from Venus. I mean, we can't detect it. We can't detect that it's making gravity. We can't point our detector at it and see it. Oh, I can feel the bent space pulling on it. We can't detect that, let alone a fluctuation in that, let alone somebody moving Venus 3 miles further away or 3 miles closer. And that would be a radical difference than, we're talking about black holes that are within miles of each other spinning, and you're going to tell the difference between this and this. And obviously that's not what they're doing. That's what Einstein talked about. They're talking about something completely different. They're saying when these black holes are spinning around each other, they're ripping each other's mass off, and that they're turning that mass not into photons, not into radiation, not into a regular form of energy, but into some new kind of energy that Einstein never called energy, bent space. Einstein never said it's a source of energy because he never accounted for where it came from. So Einstein never said there's a thing inside of the earth that's pulling. Pull, pull, pull. I'm a thing in the earth and I got arms and I'm pulling. Einstein didn't say that because that you need energy to pull. This is just crap.
Joseph Weber of the University of Maryland beginning about 1958 or 59, but most of his work done in the 1960s, built the gravitational wave detector. He was the first person to have the courage to do this.
Right. And I could build a Putin horse fart detector. All right, I'll take a little AM radio, okay, and I'll record the signal my radio picks up, and it'll be this little jiggly line. And I'm just going to tell you that, oh yeah, right there, that's Putin's horse farting. I made a detector. I detected a Putin horse fart. Now, your job in telling me and proving that that's not what that jiggly line is, how are you going to prove that's not what that jiggly line is? You're not going to be able to prove it's not that. And I certainly am not going to be able to prove it is. And that's the whole point here. I can't prove that their stupid signal is Venus farting. But they haven't proven that it's a black hole spinning around another black hole either. This is a God story, okay? This is religion. This is how religions are made. Exactly this way. They just make up a story I can't disprove. And they make it personal. He personally was rubbing the Mary vagina, and he knew that, yes, God has been here. It was expanded in space-time. And so he knows it's detecting gravity waves. I mean, why don't you just make disciples and apostles and just go full 100% religion? Because this is all this is. They just make an outrageous claim and produce absolutely nothing in evidence. So he made a detector. We'll get no evidence of what he ever detected. Did he detect Putin's horse farting? Did he detect anything? Did he detect an earthquake? Did he detect something with this detector? No evidence whatsoever about how powerful this. Look, it looks sophisticated, and it's round, and it's metal, and it's probably got wires and vacuums and so on. What did it detect? Anything? I mean, this is so bad. I mean, they just make these claims. Oh, it's like this physics girl outside in the car saying, well, they tell you not to accelerate your car too fast because it'll screw up the detector. Well, do they have any evidence that that's true? No evidence.
To figure out a way to do it that might have a possibility to succeed. And why did he have a chutzpah to do this when Einstein said it was impossible? Basically, because there was new knowledge. No,
basically he concedes. He loves playing with mechanical toys. He's an experimenter. He loves playing with this bullshit, and he just wants to be paid to do it, and that's why he did it. It's because he likes doing it. And he found suckers to pay him to build the big giant white elephant. So this is the prototype of the white elephant. The big giant white elephant that will make gravitational waves. It's so massive. Yes. So when the big white elephant is moved, it would make a gravity wave that maybe the ETs will detect.
I think knowing Joe really well, I don't think it mattered to him, but it did matter to me, that there were now sources of gravitational waves that you could believe might be detectable, black holes and neutron stars, which were unknown in Einstein's period.
So again, Einstein is the guy who brought up the idea of black holes, right? So he said, oh, it's unknown to Einstein. He doesn't understand super dense mass. Oh, he doesn't have any idea what that could possibly be, that something could get more and more massive, and what would be the consequences, and what would be the pressure thing, and what would be, and the whole argument over this whole creation of singularities. And I think Einstein kind of knew that, no, you really can't just infinitely make this gravity well, that this gravity well isn't infinite, that mathematically you're allowed to make it infinite, but practically you can't. Okay, because you can't make two electrons smash into each other. You can't make the matter become super dense. The particles won't accept that condition. And Einstein, I think, knew that, and that's why he was like, I'm really uncomfortable with this singularity crap. I'm really uncomfortable with this infinite matter in infinitely small space. I mean, it just doesn't make any sense. So let's not do this. And they just kept doing it.
But for Joe, the important thing was that there had been major developments in technology, such as lasers and computers, new technology that enabled him to have new tools that Einstein never dreamed of to do the experiment.
So again, it's just more bullshit. Like Einstein wouldn't dream of doing the experiment because Einstein knew you can't do it. Because you have to detect something so small that even Brownian motion is going to wipe out any capacity to detect it. Your Geiger counter is going like this, and you're trying to detect a signal like this. It doesn't make any sense. You can't do it.
Now, I spent 2 months in Les Ouches in the French Alps in 1963. And Joe lectured there at Les Ouches about
How interesting, not?
gravitational waves. I was a student, and I listened to his lectures, and then I went walking with Joe in the French Alps, talking about.
So this is like the John the Baptist story or something, and yeah, then I saw the golden head, and I was like really impressed, and I said, well, I got to do this. I got to go get myself one of these golden heads.
Gravitational waves and the experiment that he was developing, and I basically became a convert. That this was really exciting. Gravitational waves would be wonderful if they can be detected.
Again, for what? Wonderful what? It'd be better than chocolate frosting? I mean, it's just so stupid. I mean, this is such useless crap. This is why you got to say it's a religion, because it's like the God story. Why would you even want it to be true? It's such a horrible story. This stupid, evil God lets all this stupid crap happen. He doesn't inform us of anything and then blames us for fucking up. He doesn't show us any evidence of anything. He shows Moses. He gives Moses magic powers, but he doesn't give any of us. I can't turn no serpents. I can't turn my stick into a snake. I don't get to have any goddamn fun. And then he blames me for saying I'm not terribly interested in being part of your fun little gang because I don't get to have any magic powers. I mean, the whole thing is such a sucky, shitty story. You go to heaven and forget who the fuck you are. I mean, and you spend the rest of your life being somebody else. Oh, how fucking much fun could that possibly be? I mean, the whole thing is so stupid. You wouldn't even want it to be true, and these people are trying so desperately to make it true. Why the fuck would this stupid... Oh, the bent fabric of space is made fatter by consuming matter, or whatever the fuck it is. Like I said, it has nothing to do with Einstein. None of this crap makes any goddamn sense. I convert matter into bent space-time, whatever the fuck that is. Not energy, bent space-time. Einstein never said E equals bent space-time divided by, Putin horse fart.
And so largely inspired by Joe on the experimental side, and then on the theoretical side by my PhD advisor, John.
Yes, on the theoretical side, completely made up crap. We'll make it change in 2 different dimensions, to double the signal, and then we'll create this preposterous nonsense about somehow the matter actually gets converted into some new force added to the gravity. So the black holes have gravity as they're spinning, but they're creating extra gravity. That is, they're getting even more massive, in a way, by shedding their mass. And by shedding their mass, that is, losing their mass, they're somehow getting more massive. Makes no fucking sense.
Wheeler and a few other theorists, I decided that I wanted to pursue gravitational waves as one of the fields in which I worked when I moved to Caltech on the faculty in 1966. And yes, that's me.
So let's understand, this is the whack job who was the science advisor on the movie Interstellar, which broke every law of physics you could break. You broke every single law of reason and logic to write a silly, sappy little formula Shakespearean love story. None of it made any sense. None of it. He's a science advisor. The Dust Bowl was fake. The storms are fake. Everything had no real consequence. Everything was a fake. Look, we had a giant dust storm, but the corn's still tall and green. Look, it blew over the house, but the corn is still standing up straight. None of the physics made sense. Not just the gravitational physics or the space-time physics. None of the physics in the video made sense. The solar airplane that was in the air for 10 years made no sense. It was a jet airplane. Solar jet airplane? I mean, no propellers. No super light. From solar energy? From a fucking 5 solar panels? No fucking way. Completely bullshit.
The hair moved off of my head and onto my chin. So I built a theory group beginning in 1966 where we worked on black holes, neutron stars, and gravitational waves. And we began to develop a vision for the science that might be done with gravitational waves.
The religion. We developed our... let's write a Dianetics book. That really works pretty well. So we'll write a book called Dianetics, and we'll just call it instead, gravity wave ethics. Fuck.
they could be detected. The key thing that underlay this vision is the vast contrast between the electromagnetic waves with which astronomers...
All right, so let's understand. There's no vast contrast, okay? Einstein didn't think there was a vast contrast. That's why he basically credited Maxwell by just saying, yes, I'm basically just reforming Maxwell's equations to give you the same kind of equation for gravity. And so the things are that similar. Oh, this is such a lie, vast contrast. No, not between Einstein's gravity and Maxwell's electromagnetism. No, there's a vast contrast between those rational understandings and this irrational crap that these assholes invented that you dupes all fell for. That, the idea that you make more gravity by making stuff less massive. So I make the stuff less massive and I somehow make more gravity. Yeah, that didn't happen. Didn't happen in Einstein's era, didn't happen in Newton's era, it never happened on Earth. It's just a story, it's just a religion.
normally study the universe, light being the primary version, and gravitational waves. Electromagnetic waves are oscillations of the electromagnetic field that propagate through space-time. Gravitational waves are oscillations in the fabric or shape of space-time itself.
All right, so it's just more nonsense. Like that wouldn't be something Einstein would say, I don't think, at all. I mean, he wouldn't say these are the same, that the EM field is really space-time vibrating. No, he'd say that gravity was space-time rippling, that gravity waves were ripples in space-time, and that EM fields are ripples in electromagnetic fields. And he'd say those are two separate fields. That's what he would tell you. He'd say those are two different versions of whatever the ether is that you're making here, that those are different ethers. He wouldn't say that you have this space-time ether and then you have electromagnetic ethers, and that somehow the electromagnetism is actually oscillating space-time. No, he wouldn't say that. Electromagnetic propagation does not make gravity. Matter makes gravity. Mass makes gravity. Electrons and protons make gravity. It is not made by photons.
I've described. Electromagnetic waves in astronomy are almost always incoherent superpositions of emission from individual particles or atoms.
Right, so they're completely not incoherent, so that's bullshit. They're quite coherent in the sense that see, he's saying there one atom can emit a photon in any one of these possible directions, right? A light bulb. A light bulb radiates light in all directions. It's going over there, it's going everywhere. Okay? The gravity's doing exactly the same thing. So it should be just understood as an analogy that gravity is just like light, and Einstein would have agreed with this, except when the photon hits you, you get a little tug towards it. So if a photon hits you, it's a little pull towards it. There's a little contraction in space-time. The contraction in space-time, if you do the math, Leonard Susskind would tell you the math duplicates fluid dynamics. So it's straight line force, essentially. So all of this it's exactly the same. The only thing you've changed is that photons have a push effect. Their energy, they hit something with momentum, where gravity is a pull effect. And that's just because they don't understand the real mechanics precisely enough to understand that there's a push in the universe already. Gravity already exists in the universe as a pressure, and you don't make more gravity. You're essentially blocking gravity, okay, absorbing gravity. Therefore, something doesn't hit what it was going to hit. So material objects just stop bullets. Say there's somebody shooting a bullet at you and I'm in the way. I absorb the bullet. The bullet doesn't hit you. You get it? So you don't get pushed back. There's somebody else shooting you from behind, so you move forward. It's that obvious. This is such a lie. Again, so they say there's this huge contradiction between the two things. No, huge contrast. No. Einstein wouldn't agree there's a huge contrast.
They're molecules. Whereas gravitational waves are coherently emitted by the bulk motion of matter, or more precisely of mass and energy.
So this is more bullshit, right? The bulk motion. But Einstein would tell you that the bulk motion has to do with the little bits. The little bits have to move. So Einstein wouldn't sit there and tell you the gravity. Einstein would say exactly what I'm saying. that the gravity is made up of little bits that have gravity, electrons and protons, the atomic number, the atomic weight. Those bits are doing the converging. And when you put a bunch of vacuum cleaners together, then you get a big sucking sound. If you only have one little vacuum cleaner, it's a little sucking sound. If I put a bunch of them together, they're all sucking, then I get a big sucking effect. So it's the same exact thing. It's no different than if I combine charges, no different than if I combine magnets. So there's no inconsistency between the two theories here. So this is just such this is premised on such wrong, and again, to put Einstein's name on it, to say that Einstein would agree with any of this crap they're saying, he wouldn't.
Electromagnetic waves are also easily absorbed and scattered as they travel across the universe by matter. Gravitational waves are never significantly absorbed or scattered, not even if they are created in the birth of the universe, and they're what we call...
All right, so, and this is, again, can be proven theoretically that that's not even true. So, two things that are falling, all right, will continue to fall without getting closer to each other. Essentially, the gravity has been absorbed. So there are experiments you can do that will demonstrate that gravity is absorbed, that it is a real piece of energy. It is a real field, and it has the same properties as other fields. So gravity is absorbed. Now, scatter is another subject. You can't reflect gravity off of things, okay? Gravity isn't moving electrons in the same way. It only moves them one way, okay, based on charge rules. So you can't make gravity do an atomic function. Gravity only is affecting electrons and protons. It doesn't affect atoms. It just affects the electrons and protons inside of the atom. So you can't give it the more complex behavior. But that's the only difference. So this is more, again, just nonsense. And it would be something Einstein would not, he wouldn't agree with any of these distinctions being made as being important or significant or even real.
The Planck era. These extreme differences have some important implications. First of all...
So again, they're not extreme differences. You add up charges just like you add up particles, atomic particles, to make gravity. Again, this is just to say coherent emission by bulk motion of matter. Again, it's just such nonsense. Of course, everything is based on the net effect, a collective. But the force itself is clearly subatomic. Einstein knew that.
Well, many gravitational wave sources won't be seen electromagnetically because the emission processes are so different, the propagation, the penetration is so different, and so forth.
So again, more nonsense. The only thing that's different is gravity isn't doing the same reflection. Gravity is absorbed by objects, and it doesn't reflect the same way that photons do. It reflects, but I don't want to get into a whole complex explanation. I'm just saying that obviously gravity is absorption of momentum.
And second, enormous surprises we felt would be likely if gravitational waves could ever be detected. And so it was clear to me by 1972 that this was really the most exciting thing that I could work on if the experimenters could really pull it off successfully. Now, Joe Weber...
So again, even though the theory was preposterously stupid still, even though you had no reason to think there was any way you could make these things dramatic enough to detect them, we can't detect the gravity from the black holes. They're saying that somehow we're going to be able to detect the change in their position. A tiny change in their center of gravity, the difference between this, and we're going to detect that, when we can't even detect the gravity they're making itself.
Published a result in 1969 announcing evidence for, he didn't say he discovered gravitational waves, but evidence for gravitational waves. It turned out that he was not seeing gravitational waves in the end, but nevertheless he got...
Right, so it turned out to be fake, phony, and stupid. It's turned out to be a colossal mistake, but the mistake made everybody interested and made everybody think it's real, and let's spend the money. And so once and that's all this came down to, and because the Europeans were spending money on it, they convinced the United States government that it needed to waste money on it too. So let's have a big fat white elephant race. Who can make the biggest, fattest, biggest, most colossal waste of money ever in the history of mankind? Who can do it faster and better? The Europeans are us. And, well, no, we had to win that race.
everybody else in this field going as an inspiration for us, and he also developed much technology and some data analysis techniques that underpin what we do today. So we regard him as the pioneer of our field.
Right. The pioneer of your field was basically a guy who sold a lemon to the public. Was wrong, made a huge mistake, a grotesque error, and he's the hero of the story.
Ray Weiss was another pioneering figure. Ray in 1972, April 15, 1972.
All right, if we get to further into this video, like I said, I really hate making this thing twice. So here's a drawing. You can obviously see that, so they were bouncing, Weber already had done the bouncing the photon many times between the mirrors. And these are convex mirrors to make that possible, clearly by their shape, blah, blah, blah. And so this was clearly part of their idea of how to do an interferometer, where you can make it small and pretend it's bigger just by keeping the light between the two mirrors. So essentially lasing in a sense, right? Lasers work on a similar principle. It's a little different in the sense that as the light's trapped inside, the light is causing a chain reaction of electron states where, you know, one photon hits the electron and creates essentially two photons. The original one bounces back and the new one goes forward, so you're kind of gaining an extra photon. But anyway, that's more complicated. But anyway, both systems. So in a sense, a laser is an interferometer by this kind of definition, because you're trapping light in between two mirrors, and so you're lengthening the amount of time it's exposed to any movement in those mirrors.
He published in an internal MIT technical report the idea for and an analysis of the kinds of gravitational wave detectors that we would ultimately use in LIGO for detection of gravitational waves.
So again, we still don't have from science any real explanation of how the interferometer works. So the whole idea of the beam splitting, how you split light without affecting the light, creating two different beams. The half-silver mirror creates two different beams. One beam that's diverging, one beam that's not. One that's a reflection is different than a transmission. Just a fact. It has a different effect on the photons. They haven't explained that away. They haven't explained at all where the interference happens. They haven't explained what happens to a single photon in the interferometer. None of this stuff has been detailed. And again, they have never shown us real evidence of this tiny detection they're making in changes in distance. They've never shown us the test results of the interferometer to prove they can do 1/10,000th of a proton's width.
Mirrors that hung from overhead support, you're looking down on this diagram. And laser beam would go in, get split in half, and go down and bounce back and forth many times between these mirrors. The same thing between those. Laser beam would come back, recombine, and when these mirrors moved apart and those moved together, there would be a change in the different distance that the light in this arm traveled compared to that arm. And as a result, through the interference of the two light beams, the intensity of the light going down here to a photon detector would increase and decrease. And
yeah, so again, this is just part of the made-up part. Like, you can sort of get the obvious part that if the gravity's changing this way, you know, the spread, then the two mirrors horizontal would get further apart. But it doesn't explain how the mirrors in the other direction move. So they had to make the force change be different in the two dimensions. The two dimensions perpendicular to the travel, they had to make those two dimensions warp in exactly the opposite way to double the intensity of the signal.
It's precisely the pattern that gave you the shape of the wave that is passing. So this was his idea. The remarkable thing was that Ray then identified all the major noise sources. For the first generation.
Does that make any sense? Is it really possible for anybody to identify all the major noise sources? I mean, right now, I've used this analogy that there's geysers that we can only predict how often they erupt, because they erupt every 10,000 years. So we can only predict. We only make a guess at what their rate is because we've never seen it. Okay, and we have seen some that are 1,000 years. Well, I mean, obviously we didn't have technology 1,000 years ago to be able to hear sounds that only happen once every 1,000 years. The Earth makes sounds that happen only every once 1,000 years. It's proven by the fact that the geysers go off every once 1,000 years. Just though Old Faithful goes off every hour, there's a geyser that goes off every 10,000 years. And it's a reliable noise. And there's a whole bunch of noises like that inside the Earth. There's all kinds of movements that are happening at regular-ish rates all the time. Glaciers breaking, all kinds of stuff is happening at regular rates. I mean, you can't account for those sounds. There's no way you can have experience with them. You've detected them before in your detector. It's just a preposterous notion that you can pre-filter noise. No way. I mean, unless you're doing like my voice, and that's the only thing in the room is my voice. Well, then you can pre-filter my voice out, okay? Because it's a consistent thing that you can take out, and there's no aberrant, there's no other noises that made. There's no every 10 minute noise. There's no every 50-year noise. I mean, it's just preposterous to say you can filter this.
Of our line of gravitational wave detectors would face. Described ways to deal with each and every one of them, and estimated then what kind of sensitivity could be achieved with such a detector, and concluded by comparing with the strength of the waves that I and my other theorist colleagues were predicting, concluded that if you made such a detector that was a few kilometers long, you might have a serious chance of success.
No, he still knew that was probably not going to be good enough, okay, because he still knew that the strain was 10 to the minus 17. So he still knew he was in trouble, but he liked playing with it. But he's still in big trouble.
Now, I heard about this. I had not yet studied Ray's paper. Well, first, it wasn't published in the regular literature because Ray, being Ray, had the attitude that you don't publish something like this until after you've built the instrument and detected gravitational waves.
Yeah, why don't you just detect anything? Detect a steel ball swinging over the mirror. Again, we have no evidence of any rigorous testing, right? I mean, we crash test cars, we do lots of stuff no evidence of these interferometers being put through the process of demonstrating how good they are. No evidence at all. No published evidence of detection. Sunspot, can they detect a sunspot? A sunspot is a huge amount of mass being moved out of the sun. Can they detect it? No. No evidence they have.
And so, but he did disseminate it to his colleague. But
I mean, we're spinning on a planet. That means we're exposed to things all the time. Gravity on, gravity off. Like the moon's gravity. It's kind of gravity on, gravity off in the sense that the where the moon is pulling in the opposite direction, right? So when the moon's on the other side of the Earth, when the Earth is spun in such a way that the moon is on the other side, appears to be, I'm actually being pulled down. And then when the moon's above me, I'm being pulled up. Is there any evidence that their detector can tell the difference between those two states?
at the same time, and before I saw a copy of this or had any serious discussions with him, we were finalizing the text of our book, Gravitation, the textbook that I co-authored on relativity theory. And so I looked at the basic idea. I looked at
yes, like this idiot knows anything about gravity. So again, this is a guy who titles a book Gravitation, and then when he was science advisor for a movie, he created scenarios that are impossible. That is, where you could move from between extreme places of time dilation, frames of time dilation, and again, just breaking the law of physics, which is time dilation is an issue of velocity. Now, acceleration causes velocity, but velocity is what causes time dilation. So you have to change your velocity to change your time dilation. That means you have to go through the process of accelerating to change your velocity, right? You can't change your velocity without going through the process of acceleration. So clearly, the two things have to be in different velocities, which means your acceleration has to dramatically change to change your velocity that dramatically. And so it makes no sense. You'd have to have 10 million g-forces to travel from your little spaceship in 10 minutes and then go to some planet that's time dilated at a 20-year difference kind of rate or something. 1 minute equals 4 years or something. The only way that could happen is you'd have to change your speed in this dramatic way. You would have to go from 0 to half the speed of light in 10 minutes. And you won't survive that. You'll be flatter than the virtual pancake.
numbers, it was obvious to me that Ray was crazy or stupid or something. And so I used very gentle words in this textbook. I wrote a sentence which said this idea is not promising.
Right. And so somehow, what changed? He won't tell us what changed. He had a conversation with somebody and somehow now it changed. But what changed? What physics changed? Where did you get a different understanding of physics to say all of a sudden, oh yeah, we can detect this kind of motion in electrons, no problem. This tiny bit of motion. So let's understand that the proton is just one little tiny piece inside of a nucleus that if you had like the Superdome or something, you know, some big stadium, and you put a grain of rice in the middle of the stadium, the electron is the circumference of the stadium, okay? That's how far away the electron is from this tiny nucleus. And it's only by motion of electrons that we can detect photons. And so somehow you're going to detect the motion in an electron that tiny. No hope at all. It's just preposterous. Not even the grain of rice at the motion scale of the electron could we detect that change in an electron's motion. It's just insanely stupid.
And I'm not being pro. I spent about 60% of the energy of my whole career trying to help Ray and the other experimenters pull it off afterwards. But why did I regard this as crazy at the time?
So 60% of his career was on this nonsense, and the other 40% was writing fables, fantasy stories that can't possibly happen.
I will just look at some numbers.
Isn't that just like religion? A bunch of dragon stories and giant stories and just a bunch of silly little fucking stories that don't have anything to do with reality.
Trying to measure the motion of two mirrors using light. And I'm going to tell you how big the motion of these mirrors is that you have to measure. Let's begin with 1 centimeter, which is just a little smaller than an inch, of course. Divide by 100, you get the thickness of a human hair. Divide by 100 again, you get the wavelength of the light that is being used to try to measure the motions of the mirrors. Divide by 10,000, you get the diameter of an atom. Divide by 100,000, you get the diameter of the nucleus of an atom.
Right, so this is 10 to the 13 again. So this is all you gotta have to understand in terms of the electron. So the electron is this 10 to the 8. And you've doubled that, which is an insane amount of distance that the electron, you would be changing the distance so dramatically in terms of the size of the diameter of the electron's orbit. And this tiny little change in its momentum would have to be detected. It's just impossible.
Divide by 1,000 again, you get the magnitude of the mirror motions that we thought you might have to be able to measure in order to pull this off. And I looked at those numbers and I said, Ray is great.
Yes, that's right. So, and that's with their preposterous conversion theory that I'm going to convert matter into this energy, this bent space thing. Somehow I'm going to make space bend with something that's not real energy, not photons, not nucleuses, not electrons, not something real moving, some unreal thing moving, bent space. I've converted mass into bent space. That's not in Einstein's formula anyway. When Einstein said E, he was talking about real energy, not gravitational energy.
This is 1 trillionth, 10 to the minus 12, 1 trillionth, the wavelength of the light that Ray is going to use to make this measurement. In technical terms, you're going to split a fringe by a part of 10 to the 12. I mean, this is obviously not possible. And then
just understand, I mean, there was Einstein's theory was basically to say gravity is an energy. You know, to make it into this bent fabric-y thing, he was basically saying it's not in the conservation of energy equation. It's an emergent property of matter. It's not a fundamental or elemental property. That's what he was kind of saying. It's something else happening in a separate medium, not the medium we call that all the regular energy is in.
Studied his paper in detail. I did some more serious calculations. I had extended discussions with Vladimir Virginsky, a dear friend, physicist in Moscow, Russia, and with Ray, and I became convinced that it could succeed. Being convinced, I decided that
I'm just trying to get to the point where you understand that Einstein didn't say the sun gets weaker or has less mass when it makes gravity. So it's making gravity, it doesn't lose mass. The Earth doesn't get less massive to make gravity. It's not part of the conservation of energy. It's not in the thermal universe, space-time. And here they're playing this game like it is.
Harrison would do everything I could to help Ray and his experimental colleagues pull this off successfully. But about this time, a few years later, I guess it was probably 2 years or so later than the beginning of this story with Ray, Ron Drever in Glasgow, Scotland, had a brilliant idea for an alternative way to bounce the light back and forth in the arm.
All right, an alternative way. So we don't know what this alternative way was, and it's basically being illustrated as exactly the same way. So that instead of making the line where you can see them bouncing back and forth, they just made a thicker line. So somehow the light bounces back and forth. They're still convex mirrors. So he's there's absolutely nothing different about this design. It's exactly the same thing. So he's saying there's some sort of technical difference about how they're bouncing the light back and forth, but we're not given any of these technicalities. And they're kind of important technicalities, frankly, because if you know anything about trying to do this experiment yourself with a laser beam, bouncing it back and forth between mirrors and then having it escape, the problem is that when it escapes, it might go near the surface of the mirror, and it's going to get diffracted. So, you know, you're back to the same single slit, or you're back to the surface problem. You can't really have lasers go near surfaces without them being disturbed by the surface. Diffracted, plainly. Refracted.
I think Ray recognized before this that you could do it this way, but it was only Ron who really identified that it was possible to pull it off technically, and it would have some very, very big advantages over Ray's way.
All right, so we're given no understanding of what the difference is and what the advantage was and what the new innovation was. So this is just more crap where, you know, they created a gimmick that multiplied the strength or effectiveness of this device, and there's no theory, there's no evidence that any of it makes any sense. Again, this idea that one kind of space is contracting while the other kind of space is expanding, where did that come from? Who first suggested that happens?
Is to bounce the light back and forth, fold it onto itself by making these mirrors be the mirrors in a resonant cavity, so the light resonates back and forth upon itself, building up coherently a very intense beam in here. And
building up coherently a very intense beam in here. So again, this is more nonsense. Either if you're building up, then it's a pulse laser. You know, I mean, if you build up, like you keep shooting light in, you keep reflecting it, and then you let all of it go. That's a pulse. So that's a pulse laser. That's very different than having a consistent, coherent beam of laser light, of light. So, and the interferometer doesn't multiply the photons like a laser does. A laser multiplies the photons by having the photons hit an electron, which is essentially another mirror. Okay, so, you know, this is just such a pile of crap.
That kind of a technique then turned out to have great versatility and great power, although it was harder technically to pull it off. It is fundamentally simpler and more powerful in the end in the modern era.
All right, so that's just complete mush. Doesn't give you it just such a distortion to say that there was something he gave us any insight at all. Those two diagrams were exactly the same, and the only difference was you didn't get to see the lines moving back and forth, so they just made them compressed. But otherwise, the two drawings are identical. So there's just no information here.
1976 and 1978, I talked to my colleagues at Caltech and said, we really ought to get into this game. We should build an experimental group to work.
All right, so the other guy's working at MIT, and so he's basically just saying that Caltech said, you know, we have a white elephant gap. You know, MIT's way ahead in white elephant, and so we got to find a way to piss away some money too. So let's start making some white elephant. So he basically stole the other guy's initiative. So maybe they made friends later, but I bet the other guy at MIT was a little pissed off when he decided to be stealing his mojo.
Alongside Ray Watts' group at MIT, because this is really a very exciting field. My colleagues in the Caltech administration jumped in with both feet with great enthusiasm, and we brought Ron Drever then to Caltech to lead the effort. We also
so you paid a lot of money to you know, paid a lot of just waste salaries to try to do something that's still theoretically impossible at this time. At the time they're building this thing, it's still theoretically shit.
brought Stan Whitcomb, who began as an infrared astronomer. He was a young guy who had just recently received his PhD. We brought him in to work with Ron in leading this and to be the person, the hands-on leader in building it.
So let's just understand, they still haven't detected anything gravitational ever. They've never detected anything moving, mass moving. They haven't detected any with their instrument. And yet they think they're going to detect something a billion light years away.
40-meter prototype. detector of the sort that Ray had invented and then Ron had modified by changing what goes on in the arms of the light bouncing back and forth. In parallel with building the 40-meter prototype at Caltech, Ray Weiss and his group at MIT completed the construction of a smaller prototype gravity wave detector, and they also carried out a feasibility study for kilometer-scale interferometers, costing of them technical issues you would face in enlarging these to kilometer scale.
Yeah, technical issues still don't make any sense. Okay, about it, how this vacuum chamber itself doesn't shrink and contract, and or how the photons inside of it aren't shrinking and contracting. How the whole thing can make any sense? How you can bend the space-time and somehow the photons don't know you did it. No, I didn't know you. You contracted that space without me being affected by it somehow.
On the basis of that, of their feasibility.
So, I mean, it's just the irony, right? They make photons twice as sensitive to gravity, and yet the photons aren't sensitive at all to gravity waves. Yeah, that makes sense, right? No, it doesn't make any sense at all.
Study the prototype work they did, the prototype work done in Caltech, and prototype work done in Ron's Zeber's group in Glasgow, Scotland, and a group in Garching, Germany. We went to NSF and were encouraged by Richard Isaacson, the superb program director at NSF.
Yeah. Bullshit. This whole thing. So they went to the National Science Foundation, and they basically duped them into thinking we have a white elephant gap. The Europeans are way ahead of us. That's when the European thing came into it, because the Europeans were really interested in this crap. And they just didn't want to get Sputniked. And so to prevent being Sputniked, they say, oh, we better invest in this horse shit, because the dopey Europeans are doing it. And that's how you create white elephants. We're going to have a new religion gap, a Dianetics gap. They'll have Scientology and we won't.
To move forward in creating the LIGO collaboration. From 84 to 87 in our collaboration of Caltech and MIT in planning to build these gravitational wave detectors with kilometer scale sizes, it was led by Ray and Ron and me. This was the most dysfunctional leadership you can imagine.
Right, so he's conceding you're all a bunch of assholes, full of shit, and that's why you didn't even have a plan, because the plan was preposterous to start with, and you're basically saying, how can we get away with stealing all this fucking money?
It was almost like a cartoon. It was a fundamental issue that although Ron Drever was highly creative, he had difficulty functioning in a collaboration where he didn't have full control over everything he was doing. And there were big disagreements between Ray and Ron about how you would go about things. And I was the mediator. And by the end of 1986, early 1987, it was just clear that this was a disaster waiting to happen. And so we brought in Robbie Vogt to be a single director with the authority to bash heads together and get Caltech and MIT working together jointly, and to lead us in writing a proposal for the construction of LIGO. So under Robbie's leadership, we wrote.
So the two colleges decided to collaborate. Obviously, that didn't go too well, and and they still hadn't made anything that worked. And so then they decided to go right to the grant tour. Instead of waiting for the grant money to go to the colleges, they decided, well, why don't we just go to the grantor itself and get the money? And yes, and then they fooled the government into saying, oh yeah, this is worth $1 billion. Sure.
And sent to NSF in, I think it was November of 1989, a proposal to construct facilities in which we would place the interferometers, and we would then build 2 generations of interferometers. An initial set of interferometers that would be simple enough that we knew how to do it then, and that we really were confident we could pull them off.
Yeah, we're confident we could make something, but they still had no theory that they could actually detect anything with it. I mean, it's just such a bullshit story when you get the details. You're just like, well, eventually this will get dissected, and all these people will be just shameful dupes. Like, they should have never been in head of the National Science Foundation when they were stupid enough to say, yeah, let's spend a preposterous amount of money on something that's not even theoretically possible.
It would not be sensitive enough to have a high probability of detecting gravitational waves. If we were lucky, we would see waves, but we would have to be awfully lucky. Nature would have to be awfully kind to us. But then, with the experience we got with the initial interferometers, we would build a second.
So they still didn't have a theory. So nature, it wasn't anything about nature having to be very kind to you. You would have to fool people into thinking Einstein proposed some theory where matter gets turned into bent space, and so then you could burn 3 solar masses and convert it into a noise, and then say you heard the noise. So you had to come up with some sort of dopey theory that, yes, the farts coming out of Putin's horse's ass are much, much, much stronger than regular horse farts. And so, yes, we can hear Putin's horse farting.
generation called the advanced interferometers, which should have a high probability of seeing gravitational waves. So that was our strategy in our 1989 proposal. We struggled from 19...
Yeah, you struggled because, yeah, the people would say, what the fuck are you talking about? But they found a dupe, I think a woman dupe. The head of the National Science Foundation ended up being a woman who said, oh yeah, let's waste $1 billion on this shit.
1990 and 1992 to get this funded, and did ultimately succeed in 1992. NSF and Congress bought into this in 1992, and they never turned away from us. We had complete backing from the National Science Foundation and from Congress, regardless of which political party was in power, from then until we ultimately discovered gravitational waves.
Yes, and I have to say that's just miraculous, but it just demonstrates that, yes, congressmen are probably the dumbest Americans existing. They're criminals, liars, and crooks. They're too stupid to be embarrassed to be such preposterous liars. I mean, in every way, they have no character. So, yes, you got them to go along with a fraud. Oh, what a surprise. You got frauds to go along with a preposterous fraud. Oh, I wonder how many kickbacks they get. Oh, what state it was in, who got the financing, and what else their institutions. Well, because you gave money to Louisiana for this stupid thing, us losers in Arkansas get to do some white elephant project. So it's just an excuse for more building of white elephants.
To hand it to Congress as well as to NSF, that I'm impressed by how they stuck with us. But part of that is, frankly, that we told them we would have to build 2 generations in order to succeed, and so they were prepared for our not succeeding.
Yeah, the 2 generations. It just, again, doesn't make any sense. So they knew they were going to fail. They knew they couldn't do it, and they were just waiting for better technology to come along, because they can't do it the way it is. I mean, it's just amazing that they got money for something based on the premise that, well, we can't really do any of this shit, and we'll just waste money building it, and then we'll rebuild it again. Amazing. They did that with one of these colliders, like I think the one in Europe even. They built it, and then 3 years later, they decided to turn into the Hadron Collider. So they just undid what they spent 3 years doing. Money wasters.
Anything with the first interferometer. When it came time to move forward with the construction and to develop the detailed plans for construction, we brought on Barry Barish, who had been leading the construction of one of the large particle detectors in the superconducting supercollider, which was canceled by Congress in, I think, 94.
Yeah, so they wasted a bunch of money on a bunch of studies and a bunch of bullshit about a stupid collider that, again, can't do anything. They just do more stuff. We've done it. We found a Higgs boson. We did this. We did that. Yeah, says you did.
So we grabbed Barry and brought him in to lead us through construction, the organization of construction, and on through the early interferometers. And Barry was just superb. I think that by my judgment, and I think many people agree with me in physics, he's the most skilled leader of large experiments.
Yes, the greatest white elephant propagandist in the history of mankind. So again, another one of these contests for which there's no contest, right? If I just took any old college student and I gave him the job, would he do any worse? I mean, we really don't have the Olympics of CEOs anywhere, do we? Do we have a real fair contest where we just say, yes, all you need to do is be able to do the job? And where's the real comparisons, right? They're all, there's no credibility standard here at all. Like, you could have done what Barry did. What did Barry do that's so brilliant? Oh, he figured out, I need to hire a scientist. Yeah. And you better believe in this crap, so I better hire one that believes in this crap. Yeah, that's hard to do. Wow.
Projects that the world has ever seen, large experimental physics projects. He led us in constructing the facilities. He organized LIGO, in part expanding it to other institutions by setting up something called the LIGO Scientific Collaboration. That collaboration now has 1,200 scientists and engineers.
Right, that 1,200 publicly financed, paying the salaries for our benefits and all this bullshit for a bunch of fucking religious kooks. So this is like the Catholic Church wasting money on cathedrals. Oh, we love you. Except we really don't. We just like fancy buildings and pretty clothes and good food. Fuck you people. That's all these people are doing. We're financing bullshit. It doesn't... let's call it science. Okay, fine. We'll call it science. We're just duping people.
There's in about 80 institutions in 18 nations around the world. So, because we just did not have, by any means, enough scientists and engineers to pull this off successfully, like Caltech and MIT alone. Because these instruments are so complex, there are so many things that go wrong with it that you have to be prepared for, and you have to build into the instruments ways of dealing with everything that can go wrong.
Yeah, right, they did that. No, I'm sure they did all that. Oh, yeah, sure. And they tested it so thoroughly. Oh wait, they didn't do any of that. They proved how it works so many times. Oh no, they didn't do that. The proof that it works was in them saying we did it. Now they've proved it works because they say we did it.
Just required a very large team. He led us through the construction of the initial interferometers and their first searches, and then he left us to go back to high-energy physics to lead the design study for the next generation of large particle colliders. And we brought then on Jay Marks and now David Wrightsey to lead our project. The initial interferometers were installed and operated between 2000 and 2010. The advanced interferometers were installed between 2010 and 2015. And now we're going to pause because I don't want to tell you gravity waves were detected yet, because I want to go back and pull in a couple of other ideas. In the meantime,
all right, advanced LIGO monitor motion of 40 kilogram mirrors to 10 to the minus 17 centimeters. So again, just complete made up crap that they can do that. That atoms will cooperate. They'll stay quiet enough for you to detect little motions like that.
On the theory front, there was a very deep issue that Vladimir Virginsky, the Russian that I mentioned to you, pointed out to us already in 1968. He said that basically, no matter what kind of gravity wave detector you try to build, you're going to wind up trying to measure the motions of very big masses, human-sized masses, that are where the motion is so small that you will see those masses behaving according to the laws of quantum physics, not classical physics. Let me explain a bit more. In the context of LIGO, you have two mirrors separated by 4 kilometers. The light beams bouncing back and forth between them. You're trying to measure in the advanced detectors the motions of 40 kilogram mirrors then, to a precision of 10 to the minus 17 centimeters, which is approximately, in technical terms, the half-width of the Schrodinger wave function for the center of mass degree of freedom of the mirror. What that means is...
Yes, it means that Brownian motion is consuming any possibility of detecting anything.
The mirror, physically, the center of mass, the thing you actually measure with your laser beam, is bouncing back and forth, fluctuating where it is in a manner that is unstoppable and unpredictable. These are quantum mechanical fluctuations. And those fluctuations are at the level that they begin to...
They're not quantum mechanical, okay? You don't need quantum mechanics to understand heat. And that's basically all it really is.
Be detectable by the advanced LIGO detectors at their design sensitivity. And if you go beyond that, you have to deal with that. You have to be able to measure the motion of a mirror that is caused by a passing gravitational wave where the motion is smaller than these quantum mechanical...
All right, so again, let's understand, it's not the motion of the mirror, it's the motion of the electrons that you're measuring. So you're measuring the distance where the electron that gets hit by the photon, which is sort of a random event anyway. Right, here's a substance with electrons, and a photon goes in. It can hit an electron right here, or it can go deeper and hit an electron here. So that's always going to be random, whether it hits one here or whether it hits it deeper here or somewhere. And that noise is huge by comparison to what they're claiming to be able to measure.
Fluctuations, and how the heck do you do that? Virginsky said, well, look, first of all, you're going to see human-sized objects behave quantum mechanically. He said it has to be possible to build quantum non-demolition technology to deal with this. And so, in fact, much of the work...
Non-demotion technology to deal with this, whatever that means. So somehow, again, I could understand, like, if they really did some effort to cryogenically, make the mirrors super cold, do some things to take out all the heat out of this system, that, you could settle the electrons down a little bit, but they don't do any of that shit.
Worked in my own theory research group, in collaboration with Virginsky's experimental research group, from about 1980 up until the present, has been devoted to conceiving the ideas for and developing the technology for this quantum non-demolition. So this just gives you a sense of the challenges here. And as we go into the future, this is a huge piece of the experimental effort, the so-called QND technology.
Right, so they really haven't solved this problem. He's just brushed over it like somehow we're working on it. It's a fundamental problem. Yes, the whole thing is still theoretically crap, but we're pretending it works, so isn't that good enough? I mean, pretending works, isn't pretending perfectly good? I mean, he's talking about it as if they need to make this thing better. Well, I already detected the motion of a 10,000th of a proton, and you've detected your black hole spinning, so what more do you want? You've done the impossible, so why do you need to make it better at doing the impossible? You're going to do the double impossible next, or the triple impossible?
On the theory front, there was another issue. I expected the first thing we would see would be collisions of heavy black holes, and that is what we did see. But we could not predict what the signal would look like. We could predict while they were spiraling around each other, but not when they were colliding. And the collision waves would be the strongest waves. And so we had to have computer simulations. We had to use...
There's no such thing as a collision wave. So again, this is just more shit. It's a merger, right? The two things are spinning around each other, and somehow, for some dopey reason that's unexplained, they are going to crash into each other. And the crash will just be a merger. And again, this fake notion that somehow it still has to create it's got to be converting masses when it's out here for us to see the initial signal. So somehow it has a proportional amount of mass that it loses through the whole process, and then it loses a little extra. That's the chirp. A little extra when the two actually merge, that somehow a little extra amount of matter is converted into bent space. None of it having anything to do with Einstein. Just keep saying that. They keep using Einstein's name like it was the source of this crap. And no, that's not Einstein's crap. Einstein didn't make this shit.
Computers to solve Einstein's equations during the collision to figure out what the shapes of the waves would be. And then when you saw the waves, you would have to be able to go back to the computer simulations and compare with the computer simulations to deduce the details of the black holes that were colliding. So we had to have simulations. Simulations are not going...
Right, simulations made of not Einstein's theory. They put in some new theory. So again, this is just where they're lying. This isn't Einstein's math. This isn't Einstein's theory. Einstein had no E equals bent space.
Well, because of a variety of very technical problems. And so in 2001, I myself left day-to-day involvement with the LIGO project and devoted my energy then for the next few years to building at Caltech a group doing computer simulations of colliding black holes in collaboration with a group at...
Right, so they did these blender things where they just actually photograph a blender and then they put CGI on top of the swirls made by the blender. And they say, this is reality. We says so. We says so. They said that. They actually said that. We said so.
And now it was already going, and I judged as the best group elsewhere in the world. We built what is called the SXS project. I should emphasize that just as I did not build LIGO, similarly, I didn't write the computer.
Right. So this is the joke of the whole thing. He left because he probably said, this is stupid. We're not going to, he wouldn't have left if he thought they were going to detect a gravity wave. Right? We can understand that, right? You know it. I know it. He wouldn't have left if he said, oh, we're 3 years away from, a few years away from getting this thing to work, and it's going to be great, and we're going to be famous. Yeah, bullshit. He left because he said, this is stupid. It doesn't work. They're just, this is a dead-end job.
For SXS, all I did was provided some scientific vision for where we were going and judgment as to what kinds of accuracies need to be achieved and things of this sort.
Right, so he consulted like he did on that preposterously evil, stupid Interstellar movie that was just such a fraud against science. Fake, phony, just a complete slander of science, the scientific method, logic, Newton, Einstein, slandered all over the place. Just a piece of steaming fucking shit.
It was really the younger scientists who pulled everything off technically in both the experiment and the simulations. Okay, back to September 14, 2015. The advanced LIGO detectors just gone into operation. They were being prepared for their first search. The first search was supposed to begin about 3 days later. They were just being tuned and brought into the final state. They're very complicated, as I say, and there's a lot of tuning to do.
Right, so then why don't you just test this stupid machine, right? So at that end, there's a mirror. Put a little steel ball, a wrecking ball, above the mirror and just swing it back and forth. And see if the mirror senses the gravitational wave created by the mass moving. Now, no such test done.
Bring them to the final state and begin the search, when suddenly the first signal came in. So the experimental team froze the state of the detectors. They said, this is the final state. Our search has now begun. And the search then, that first search, continued onward for several months. The first signal that came in, this is the raw signal with bandpass filtered. So you throw away everything at frequencies below 30 hertz and above about 300 hertz. Because the detector is noisy at those frequencies, you just keep the raw signal in between.
Right, it's noisy at those frequencies, and they pretend it's not noisy at these others, which doesn't make any sense, right? There's stuff spinning, logically, there's stuff spinning this fast. There's just as much stuff spinning this fast, and just as much stuff spinning this fast. What a pile of crap.
This is the signal then, the raw signal, no fancy signal processing in Livingston, Louisiana, essentially the same signal in Hanford, Washington.
Essentially the same, but not. If you really look at it, there's ups where there should be downs and all that kind of stuff, so it's not consistent. You're saying, well, how can you have that much inconsistency where you actually have an up in one signal and a down in the other signal? So isn't that sort of a giveaway if you can have that dramatic an error? I mean, it's completely wrong. it's as wrong as it could be. Let's just put it that way. You know, just saying. Isn't that indication that maybe your computer software is working a little too hard to make them the same?
By then cleaning the signals up and comparing them with the SXS.
Yeah, it's cleaning them up, meaning making them be the same signal. Yeah.
Numerical relativity simulations. The simulations are in red. The cleaned up incoming signal is in gray. It could be deduced then through those comparisons. But what had been seen was two black holes, one weighing 29 times what the sun weighs, the other 36 times the sun's weight. It's a total of 65 solar masses. They collide and they merge. The final black hole only.
So all that's just speculation based on the frequency of this wave. That's all it is. And there's no real theory. Again, there's no logic to any of these velocities, right? We're talking about giant things moving half the speed or 3/4 the speed of light, incredible speeds that they're rotating around each other in this little diameter, these super dense masses. And again, there's just absolute no theory that you convert their mass, you make them lighter, and somehow they make more bent space by becoming lighter. They create more gravity, a louder gravity signal by becoming lighter. That's not Einstein's theory. Whose theory is that? Whose name should we really put on that, Kip? Who made up that crap, Kip? Who? It's not Einstein. This might be a good enough place to end. I will perhaps watch the rest of this crap, but it clearly doesn't provide any real details. Nothing new at all. Like I said, the only new fact I've learned is the fact that they're bouncing the light. So they say these 4-kilometer arm. Well, no, it's really 1,500 kilometers because they're bouncing light back and forth. But anybody who has any logical skills can understand if they're bouncing the light back and forth, then any errors will be multiplied. That there's a real danger in reflecting the light. And the danger of it multiplies the theoretical problem the guy was talking about the mirror. What I would call the thermal problem. The quantum variant problem, whatever he calls it. I mean, it has you don't need quantum to understand that electrons don't have stable positions. And so if you're reflecting it back and forth into the mirror, that means you're hitting the mirror more times, which means you're multiplying this effect of the randomness of what electron you're going to hit, a surface electron or a deeper electron. You're multiplying that randomness with each impact. So you're making even more noise in the signal with each reflection. How can that logically be okay? Who am I talking to, right? It doesn't matter. It's a waste of time, human race. Alright, anyway, till next time and such and so forth and whatnot. This is like a 4-hour video because I had to make it twice. It wasn't as bad as I thought. I kind of pretended I didn't hear any of that before. I haven't seen this part yet, but I'm just saying. So anyway, till next time. Like I said, if there's anything in here that is new, I'll let you know, but I doubt that there'll be any new information. So, till next time and such.